That's good.
Okay, how about now? Okay. So the research I'm going to be talking about today is something that I've been working with prior to coming on with FIA, and none of this would have been possible without the foresight of John Shaw and the intestinal fortitude to deal with boxes and boxes of increment cores. But I'm going to sort of detail the evolution of a project that the FIA data were never intended to do. And it deals essentially of taking the increment cores collected primarily during the periodic, but also some of the annual inventories, and doing some novel things with them. So we all love taking increment cores. I'm sure everyone in this room has done it before. And in a forestry context, we tend to think about increment cores for age or vigor. But what we're going to do is add a third layer, the dendrochronological layer, to this analysis. And so we're interested in attaching a calendar year to each of those rings. And in so doing, we have a much stronger data set to use for a whole host of potential science applications, and I'll talk about some of those. But first I need to introduce this concept of synoptic climatology, because that's ultimately where we're headed with this tree ring data. This left panel here you see is just a screenshot of the upwelling of cold water in the southern Pacific, and that's actually the origination of what we all think of as ENSO, El Nino Southern Oscillation, or what some people call the Southern Oscillation Index, and we're all aware of that in terms of our local weather patterns. We've all heard about it. But this particular index, which has been really nailed down with instrumental data, so data maxing out perhaps 100 years, is probably a long-term climate driver in the growth of our forests, their distribution, the occurrence of particular disturbance events. Speaking of disturbance, we're having a small disturbance in the conference room. Having a concept of the instrumental period is useful, but in order to carry analyses of these sorts of patterns back in time, we need proxy data, and that's what the tree ring data serve as. So, and that's particularly problematic, especially in the western United States, where we have really a paucity of instrumental data stretching very far back in time. In the left panel, I've just plotted up the locations of tree ring chronologies from the International Tree Ring Data Bank for the state of Utah. And we can see that the the spatial density of those plots is quite coarse. And so nailing down relationships between data at those plots only gives us a very coarse evaluation of potential relationships, and the panel on the left are good historical climate data, and again, they're very few and far between, with records rarely stretching over 100 years. Now, the reason that those data are well, here's an example of how we can use gridded tree ring data. The panel on the left are the locations of the chronologies used to make the gridded PDSI index. So when you're using PDSI records in the western United States, this is almost certainly where it comes from. It goes back in time about 2,000 years, and these are the sites where that data, those tree ring data exist. Now, the panel on the right is a spatial correlation between some of those sites, and what we can see is the patterns are extremely broad and the correlation is quite weak, and most of that has to do with the fact that there aren't very many data sets to work with. Now, coming back to the Southern Oscillation Index, using the instrumental period data, we have developed a very strong understanding of how this index drives our local climate patterns. So what we're looking at here is a map of the correlation between that index, which is just a measure of sea surface temperature in the Pacific, with our dry season precipitation. And what we can see is there's a great significant negative relationship in the southwest and a great positive relationship in the northwest. And this hinges on what we call the dipole, so that area in white in the center where our predictive capability is 0. And you notice that the room that we're sitting in is located in that dipole. So this is one reason that climate on the Wasatch Front is oftentimes predicted incorrectly. We don't have control of this. We don't have the data to understand these relationships in these areas where predictability is low, where the relationships are low. So let me introduce the Utah portion of this data set. We have measured and standardized tree ring data from the Utah periodic inventory, and the result on this map are the plots where we have tree ring data from the Utah inventory. So we have a spatial density of trees that's far surpasses anything that currently exists in the western United States. Now, here's another quick look at the data. It's strongly dominated by pinyon pine. As you know, that's our most dominant forest type in the state. But then we've got some other big players in there: Douglas fir, Utah juniper, ponderosa pine. This is important to note for what we're going to be using these data for in the future. And then I've plotted up a frequency distribution of essentially the ages of those trees. So what we see is they're centered around 100 years, which we know is essentially the disturbance history of the West. But we do have a lot of older trees in there to work with. I'm just going to mention briefly, because it's not worth getting into detail for this presentation, that when we're doing dendrochronology, we tend to follow some rules to maximize the signal that we're after. And by taking, I'm just going to say we're ignoring those rules. And the trade-off is that we have, essentially, is the spatial density of trees. And so we're going to approach subsequent analyses with the brute force method and just throw a lot of data at some of the analyses. There are trade-offs here, and I'll show you in a couple of slides how we're going to reconcile some of those. And I can't talk about doing this without mentioning where the bulk of the time and the money goes: processing the data. So it's fun to take cores, but then we got to mount them and sand them and measure them under a scope, digitize them, and then we cross-date them. That gives us the control, the temporal control. Each ring is associated with the calendar year. Then we go through a suite of analytic approaches to standardize that data into time series, which we can then grid and put in a map format. And so this is where Simon Wang from Utah State University comes into play. With John driving the project and me managing it, Simon has been critical in helping us manage these, what are ultimately 5-dimensional data sets, in a reasonable way, so that we can look at them with other gridded climate data. But here's an example of one of our earliest case studies. We've just taken the Douglas fir tree rings cross-dated out of the state of Utah, and their locations are in red there on the map. And the panel on the bottom is their average relationship over, I believe, the last 300 years. And on average, these trees all show common signals: the 1980s pluvial, the 1930s drought. So there's a common signal in some of this tree ring data, which is a good sign, and there ought to be, because they're cross-dated. This is just a plot showing the distribution of ages across the state. We have trees as young as 30 years old, but also in this particular data set, trees that are over 400 years old. So in comparison to a standard approach where we would seek out the oldest trees, but then we're sampling subjectively and not objectively, which is what we get with the FIA grid, we get a different range of ages, but we still have, again, we still have sampling spatial density that's far superior to any other product. So how, I mentioned earlier that we're totally ignoring some dendrochronological assumptions. And so one way to check this is to see whether our gridded data match tree ring chronologies collected in the conventional way. So I took the Harmon Canyon chronology outside of 9 Mile Canyon in Price and just did a spatial correlation with our gridded data set and that chronology. And what it shows is very, very promising. All positive correlations except in where there aren't any data in the West Desert. And the strongest correlations occur in the driest sites, which is exactly what we would predict. So this is the first line of evidence that the gridded data from FIA are going to be a useful climate proxy. The next thing I did with the data is I split it into north and south components, again reflecting what we know about the Southern Oscillation Index, and just did a spatial correlation between the gridded Douglas fir and water year precipitation from the prior year, as that ought to drive tree growth, the amount of water delivered prior to the growing season. And what we can see for the south is, again, very strong, significant correlations that extend well into Mexico, but attenuate as we get north. And then with the northern data set, just the opposite pattern. So we're starting to see evidence of that signal of the Southern Oscillation Index in the gridded tree ring data. So this suggests that the data are good as a climate proxy, but also that something else that has slipped my mind. I'll come back to it. And I'll just skip that slide. So now I'm going to show you a series of slides that Simon put together just recently, again with the Douglas fir data set. Now we've taken the Douglas fir gridded data set and run a spatial correlation with the half-degree University of Maryland gridded precip data set, again for water year. And what he's showing you here, all the contour lines are significant positive relationships between gridded reanalysis precipitation data and the Douglas fir tree ring data. This is very strong evidence, very strong suggestion that we can use these data as climate proxy. Very promising results. We then did the same spatial analysis with the calendar year precipitation. So an arbitrary definition of when precipitation falls. And it turns out in Utah, where we have a couple of different, where we have a monsoon-driven precipitation regime and then a Pacific-driven precipitation regime in the north, that sort of metric doesn't work out very well. But if we take the difference between the water year precip and the calendar year precip, it nicely defines, based on the tree ring data, it nicely defines a line that you'll notice is very strongly associated with the dipole indicated in the lower right panel there. So this data is indicating the Southern Oscillation Index dipole independently. So there's every indication we're going to move forward with this data and use it for these sort of climate proxy reconstructions. Clear difference in seasonal precipitation regimes here. We're talking about hydrology here. And then the last thing that Simon did that's rather speculative is he took the Great Salt Lake elevation. The Great Salt Lake is a closed basin. It's a low-pass integrator of precipitation and hydrologic variability over long time periods, and correlated that with our gridded Douglas fir data set. And what we found, again, all the contour lines indicate significant and positive relationships, although they vary. So we're starting to get a real strong, what we're essentially identifying here are areas that contribute over the long term differentially to Great Salt Lake flow. So we're establishing a dendroclimo-hydrologic zone over the Wasatch Front. I'm not going to say that word again. So I just ought to mention that the Douglas fir worked out great, but pinyon pine, two-needle pinyon pine, is known to be the workhorse in dendrochronology research, it's by far the most precipitation sensitive species that we know of. We have about 700 of those in the state. I'm in the process of cross-dating and gridding those right now. We're going to be doing the same thing with pinyon pine. We've got a whole bunch of Wyoming processed, most of Montana, and I should mention that from the boxes that we have in the lab, this is the Intermountain West, hopefully you can see that. These are the sites potentially where we still have tree ring data to process. So we're hoping to have a gridded product that essentially covers the western US that we can ask these sorts of questions with. In conclusion, I'll just mention the so what of this sort of analysis. I've never spoken to a climatologist whose jaw didn't drop when they saw the spatial density of this data, of these data. So it's multi-species. We might have a proxy for precip. We might also have a proxy for temperature. We might have a proxy for drought. We can do the response analyses to decide that with this gridded data set and divide it up accordingly. It's going to be incredibly powerful. We hope to grid it in the NetCDF format, add all of the attributes of FIA data to it, and make it either 4 or 5 dimensional data so that it will be useful to the greater climate community. We're exploring these fine cell climate patterns. One question is nailing down the Enzo dipole over the Wasatch Front and the details of that, which no one has done before. We're also going to step back and look at the FIA plots further back in time. So look at spatial temporal relationships of forest growth, classic forest biogeography, which clearly will interact with climate, and we've yet to work that out. That's where this is headed. I think that's the end of my presentation, so I'll go ahead and take questions if there's time. The question has to do with the sampling protocol. Some trees are cored at breast height, some trees are cored at the root collar. Those tend to be the woodland trees. Not that I know of. We haven't run into any issues with that. That'll come up when we analyze the juniper specifically. The next question is whether we separate the ones that are measured multi-stem, where only one core was taken from one of the stem, versus the ones that aren't. And the answer is no. The question is, are there any publications on this yet? And the answer to that is nothing in print. But be on the lookout in the near future. Actually, go to the FIA Symposium. I'll be talking about this specifically. Yeah, non-peer-reviewed publications have come out of this, and you can go to my Google web page and see that. But those are all non-peer-reviewed. We're gearing up for a pretty big project. I noted there that we're doing the climate through pursuing NSF funding, and we're going to be pursuing USDA funding for the biogeography. This is a very long-term, quite large project. Okay, next up will be a very exciting talk by Chuck Woodstack. Riveting.
keeps shifting back over because you're too wide, so you're just going to have to be faceless.
Oh, that's fine. You guys can all see me, right?
You're sparing the online audience.
Exactly. Yeah, exactly. He's like, I know that guy. He owes me $5.
Just give us a heads up on the chat. We'll just keep an eye out for something to pop up.
Oh, okay. So it's just kind of formulating.
Now you're going to have to go to the first slide.
Yeah, I am on this. I am on this page. Now I'm back to that. I matched that. Now go? Okay. Oh, I see. It was probably in. Aha, there we go. You guys can see it all backwards and be like, that's totally not what I expected. Exactly. You'd be like, hey, wait a minute. See, I have the luxury of giving a talk in front of former employees and new employees, which is kind of like, or not employees, colleagues. They're all my employees. Exactly. Yeah, technically speaking. Anyway, you know, I'm gonna plead similar to what Troy did. I'm new to FIA. I used it a little bit back when I was at RSAC, and it was always given to me because I couldn't actually look at it. So, you know, I'm trying to get into the mode of using our data and finding out how much data there actually really is and how long it takes to actually learn the data set. Chris Witt said, he goes, it's been 3 years and I just barely started learning how to understand how to get into the database and actually look at data. And I'm like, sweet, great, that gives me 6 years. So one of the things that we've all been kind of talking about as far as, you know, Sarah and I and other analysts in the group, seems kind of rudimentary, but we're talking about attaching climate data and other ancillary data to FIA plots. We typically have, you know, done this in the past as part of you know, data mining exercises and things like that. But with FIA data, again, the scope and the breadth and the amount of data that there is to go through the analysis or to do different kinds of analysis is at our fingertips. But we don't readily always have it attached to larger data sets, such as things like, you know, climate and soils and topography data. So just started kind of really delving into it and looking at it and seeing all of this and being like, wow. And John always says, because when I got here, I had how many years of work ahead of me, and I still have double that, and it's been 9 years later. So yeah, that's what I'm learning really quickly. So again, we're attaching ancillary data to some of the FIA plots to provide this new information. Hopefully this is going to facilitate some consistency in our analysis of the issues that are important to us, like insects and disease, noxious plants, mortality, and encroachment. Fortunately, and at this time, we're not going to be making this data available because of confidentiality. But as Jim mentioned earlier, a lot of the analysis could actually be done with the public data, and the ancillary data can be replicated to produce similar results, especially at the scale from which we're doing the operations. So what data am I talking about? Well, again, like I said, FIA, we're data rich, but we like to analyze with other data sets. So as I mentioned, climate data, some of the soils data, and topographic data are things I want to kind of take a look at and discuss. Climate data, especially, you just heard from Justin's talk, is kind of new to at least us, the way we've been talking about it. But now he's springboarded and gone off in a direction that's pretty phenomenal with some of the results that he's getting. Sarah just recently put together some PRISM normals for the entire data record. And I kind of stole this graphic from her, outlining some of the data sets that we're interested in looking at. PRISM and DayMet we've used before in the past, but kind of didn't really optimize them the way we maybe wanted to. NAR data and VIC data are two new data sets that we've just newly discovered, but apparently have been there the whole time. And when we all took that climate data class from Simon up at USU, we started delving into it and being like, okay, great, this is some new data that we can actually use and process, and we started seeing some preliminary results of that, and it's coming out very telling as far as our variables go. There's a lot of different sources of this data that we can use in this modeling and analysis. Some of the biggest things that we've been seeing is spatial and temporal resolutions, influencing the results depending on what's being analyzed. So local versus regional mortality with mountain pine beetle. Some of the other things we're trying to determine as to what you use is the continuity of the data. You know, like DayMet, here we go. It's from basically 1980 to 1997, so the data record stops then. We're looking for data that's consistent that we can project in the future, just like our FIA plot data, this idea of this strategic design. Some of the other things about this processing of this data is kind of different and complicated. Haven't worked a whole lot with the NAR data and not at all with the VIC data. Prism data and DayMet data, lucky for us, it was always kind of ginned up and ready to roll. But there's a different architecture as to how that data actually gets processed. And you know, depends on what you're using. We started using a GRADS program to create all of these different climatological variables that we could use as gridded data, use the gridded data, export it to a format, and start data mining it with the FIA plots. Kind of a little bit different compared to the Prism and DayMet data sets, but again, we're kind of all going through this and learning it. So I took the data that Sarah ended up putting together as part of the winter work program this past winter, and I thought, well, let's just look at a simple relationship and see what kind of things are telling from this. So I took the Prism temperature 30-year normals and the precip 30-year normals and just plotted against some forest types and forest type groups just to get an idea as to what relationships we could start seeing with some of this data. And simple relationships started to kind of emerge and say, hey, I can kind of start seeing how this could actually be used in separating some of the separating these types with the climate data. Now, what happens when we actually start looking at some of the FIA plot variables? I'm not sure yet because we haven't done it, but these are things, if we can see these simple relationships, I kind of anticipate there's going to be a lot of information gained from using it. I threw an Aspen there just as a side note because I know John loves Aspen. Soils data, to me and to my former colleagues, it seemed like soils data was kind of an enigma as far as what we were using it for. We would throw it into the hopper, and we would go, oh, it's hydric soil. It's all hydric, because we're all in this really small area. It was just a very gross scale kind of product. Now with using some of the phase 3 attributes or FIA indicators, I realized that, hey, we have soil attributes that are collected on the P3 plots. But based on kind of what Michael was saying, you know, there's 1/16 of the P2 plots, and we actually stopped collection of the 2011 and 2012 year plots due to budgeting. And at the same time, Chris Witt was looking at some analysis for cheatgrass and pinyon juniper and trying to do predictions of cheatgrass within PJ stands. And so he was asking me if we had any soils data linked to any of the plot data. I started looking around and I realized that what we had was NRCS soils data aggregated to the EcoMap subregions, which was a little bit too coarse for what he was actually trying to do. So I got in touch with some people from the NRCS and realized that, wow, their data is a lot more easier to use than it used to be, for me at least anyway, the casual user. So we started looking at the possibility of using this NRCS soils data to kind of complement the phase 3 soil attributes, or perhaps instead corroborate NRCS attributes with P3 attributes. There we go. And once I started delving into the viewer, I realized that they kind of pre-canned all of this data together for us from the polygons. So they have the StatScope polygons backed with the Sergo database at the state level, and started producing all of these attributes for us already for each one of these polygons, which we could simply just run through ArcGIS, kick out layers for the entire state, and then start data mining some of these properties with our FIA data, and then attaching it, which I just ended up giving to him for his Great Basin study. And so he's going to start looking at these variables to see if there's any correlations between these. There's independent variables to see if there are any value added to some of the data that he's trying to process, as opposed to, like I said in the past, kind of with data mining, it was too coarse for what we were actually trying to look at. Now that we have this state or regional perspective, with these finer grained polygons at the map unit level, we can actually maybe start seeing some relationships. That's just a graphic of the soil data viewer. I just ginned up some stuff for him all over the Great Basin, and like I said, just pulled in some of the plots and data mined it, and he's pretty happy actually so far. In doing this, two of the NRCS soil survey attributes are not consistently populated for all the states. And they are under the vegetation productivity folder. There's 11 attributes total, but two of them, when we were discussing this with John, forest productivity and then forest for cubic, is it forest productivity? Oh, site index and forest productivity. So cubic feet per acre per year and then tree site index. That information isn't populated for much of Utah. But we collect that data. So we're kind of starting to talk with NRCS to kind of maybe determine if we could actually provide this data to them and then turn around and populate their database with some of our data. They have protocols in place for measurements and how they actually do the inventories of their soils, but there's a chance that we could actually start giving them data back as we're using their data. The last piece, topographic data. In the past, we've been using it at a variety of levels, most rudimentary, kind of like aspect, slope, elevation, and using it with our vegetation modeling process. But when I was formerly back at RSAC, we began looking at a series of topographic data derivatives that could be correlated to vegetation distribution. And Bonnie Rufinot put together a series of tools that could go ahead and create a variety of a variety of topographic data for us to take a look at and start data mining. So these additional derivatives can be produced, things like curvature, heat load, slope aspect transformations. Some of these data we're going to start generating at state level and then also at the, basically start mining our data, the FI plot data with the topographic data to kind of start being able to use this in some preliminary analysis and then move on forward. And that's it for me. Yeah. Any questions? Sure. Mr. Mark.
When the soils information is great, there's only one data that's the climate data. Are you actually going to like attach to the data, the FIA data, the climate information for the year that it lists? Like, does that make sense?
Yeah. Yeah, like you say, like the monthly totals, for example, like monthly precip or temperatures. You know, we haven't really talked about it. I've just been like.
How do you do that? See, we're running into the same questions with trying to exploit some of the FVS data set.
Right.
Because, you know, if people want to know, well, do rangeland fires burn hotter or colder than some other kind of a fire? Well, you only have land cover information at the
For a
snapshot.
right.
From 92 or 2000. So, go ahead and read.
Oh, right. Mark had a question about the climate data as to whether or not we were going to correspond the climate data collections with the collections of the field plots inventory data. Not quite sure at the time. Sarah?
Yeah, I would say that the availability of climate data for the date of a specific field survey will probably come out at about the same time we get our data. Time frame.
Similar flag.
Yeah, and so we do plan to update that information, but also we're keeping in mind that there is a time lag, and we're still looking into that. I know that some of the bark beetle studies have identified a lag of 1 to 2 years, related to precip. I think it's probably going to depend on what the question is.
So it might be that you just annual precip for the year plus minus the year collection, then the year collection minus 1 year. You might go back a couple of years or it doesn't.
Yeah, because it seems like it would be variable depending on where you're at.
The ultimate goal is to have an entire instrumental record for wherever we have it.
Okay.
So when you're into that analysis mode, this is the thing. Part of the goal of this was to not have to go out and line the spatial sets or whatever it is right with every time we wanted a question. What we wanted to do is table the values so that we could do these sorts of things very quickly and ask those types of questions, but have it all sit there and be able to compare what different sets.
So it's a resource for your analysis.
Yeah.
Right.
But already tables, already part of the database,
Right.
just run those.
Remember, you have people online.
Yeah, so maybe just summarize that, but let's still fiddle with this thing.
I should just hand this to you for that matter. We're still lining it up.
The people out in the world are
Yeah, they see the slide.
Oh, okay.
They don't see,
and they're hearing.
this is our screen, so
Okay.
for them, just kind of recapture the conversation here.
Oh, right. What they were discussing was the fact that the data in-house is kind of for us to be kind of ready to use the data for any kind of analysis that we want out the door. We don't have to, every time a question comes up or somebody wants us to examine some piece of information, we won't have to actually go out and mine the data for every new project that comes along. We would just have the data in the can, maybe part of the view or something like that we're part of IM that we're talking about restructuring on some of the stuff. Remember that? And actually have the data ready for us to be able to do analysis whenever we need to. Okay. Anything else?
Yeah, there's just a little lag there for some reason. Okay, that'll fatigue on the part of that. It's just not. You want me to try starting a new one? Okay. One talk from the end and it seizes up. Can I comply? It's got the red light up there. That's a good sign. Okay, I guess I'll do the intro while it's getting stretched and all that. Last talk of the day, in terms of the technical talks, is going to be on what Alicia mentioned a little bit, is the Forest Vegetation Simulator. Yeah, mine's sort of in mid-presentation. You zooming it back to the beginning? Okay. FVS, as it's better known, is the official model for forest dam projection within the Forest Service. It's used by a lot of other people in a lot of other places. But as I'll get into here more in the outline, there's always been a concern, it's been around since the 1970s, about it being a black box and about what's really driving the models. And depending on the skill level, the experience level of, that's an interesting one. Yeah, spawn another, maybe just another window, or just toggle the Alt Tab. There might be another one hiding back there now. Depending on the skill level of the users, they may or may not have just, compensated for inadequacies of the model, or done the calibration, which it has the capabilities of. And I've been a long-time user of FVS, well before I come into FIA. In fact, FIA-wide, we probably have more FVS expertise in our unit than all the rest of FIA combined. Justin's a long-time user. And so, as I talked to the manager of the program over there, I'm also on the national steering team that helps drive what's happening with FVS nationwide. We had discussions about validation, and so for the last 4 or 5 years, we've been discussing ways that we can merge these two big programs. So you have this suite of models that covers the country from coast to coast, and then you have this suite of plots and analyses that covers the country from coast to coast. Can we, and both of them are very important parts of the Forest Service, and again, also reaching out to a lot of other user groups. So how can we merge the two of these into some sort of systematic way that they kind of support each other, or there's some sort of feedback there where we're getting the most out of it? So that's the gist of what I want to talk about. Oh, just Alt Tab and because it's weird. Okay. Next one up. There you go. Yeah, we missed. Right there. Everybody getting done with their day and logging on to their system. Yeah. But the wired part really stinks. Yeah, so. No, you can't do anything from there. That's just a dummy one. But I've got it stretched out. For some reason, it's not showing here. But scared it. Pretty weird.
What's odd now is this one is still small and that one's big. Okay. Hey, okay. Okay. So I already got into this a little bit about what the issue is and who uses it. So I'll skip over a little bit of that. Mine's like the size of a quarter up here. Anyway, it's so I'll look at that one. Push the button on here. But it's a very versatile program. It's a single tree distance and quasi-distance independent model. But the big take-home message with FVS is that if there's something you can do in the woods or something that happens in the woods, it can pretty much simulate it one way or another. Fire, silvicultural treatments, damages by insects, all sorts of stuff. And of course, we have a lot of data on those sorts of things, and that we could potentially throw at it, in addition to just the basic stuff of growth. So it's maintained by the Forest Management Service Center, which is part of National Forest Systems. It's a Washington office detached unit over in Fort Collins. Right now, there are 21 regional variants, and a lot of those have different kinds of extensions depending on where you're at. There's 2 more in the works. The Acadian is going to cover the Northeast. Anyway, within all these variants, if you're in Utah has its own variant, for example. Even within that, like for each national forest, each model is parameterized separately, potentially. So there's hundreds of, or thousands of different parameterized models if you're looking across the whole country. And that's basically the way it's laid out. They stretched, when they did this map, they used to have the map that only covered the actual like forest area where it was, but people wanted to say, oh, I have a plot here, now which variant do I stick it in? So they went ahead and just sort of filled it in, and of course I don't think anything has ever been fitted for Nevada for the Utah variant. So that's a good example right there of the kind of potential we have. But again, it's a wall-to-wall program. You have all these, I mentioned all these submodels, and here in a little schematic like this, they look fairly simple, but something should be as simple as the height dubbing model. In other words, you could feed this model very little data, just the diameter, and it will fill in the heights of the trees if you don't supply it. Well, there's 4 different height dubbing submodels in there depending on the size of the tree and how much other data you might have. So again, we're talking hundreds or potentially thousands of little submodels or equations in there. And one of the questions, that's some of which we already know, that's fairly obvious, is, do FIA data apply to some or all or majority or whatever of all these submodels? And there's some that it's pretty obvious. The growth models we apply pretty well to. There's other things that were developed on the side that neither the FVS side or the FIA side have ever really developed directly themselves, like allometric equations and things like that. So we can't really go back and forth with those types because they were developed by somebody else for different reasons. But the ones where it really counts is where we want. And I did this slide several years ago for the FIA symposium. I've sort of hybridized like 3 different talks here for different audiences because several years ago I talked about the value of FVS to the FIA audience. More recently at the FVS conference just a few weeks ago, I talked about what was actually supposed to be a little bit of a sales pitch on why FIA data were good for FVS users. But I was like the last or second to last talk of the day. I think, no, it was last of the day because the one guy didn't make it. And what was supposed to be a sales pitch turned out completely different because the 8 or 9 talks that preceded me during the day, from the very morning up until when I talked, all but one used FIA data somewhere in the talk. So it became a whole different ball game in terms of how we're doing it. So it just reinforced the fact that we need to do this sort of marriage that we're talking about. I won't go into that about the who, but it's lots of different folks. So again, I mentioned that a little bit while we were fiddling about the user concerns. There's always the models apply to my stand. Why doesn't it project my stand the way it's supposed to? My back 40 doesn't produce the expected results. Don Vanderdriesche, who was up until recently on the FVS staff, published a paper in which was one of the National Silviculture workshops called FVS Out of the Box. the National Forest System silviculturists are probably as a group the most intensive users of FVS. And he was trying to get across the point, well, no, it's not, you can't just take it out of the box and use it, you have to do some calibration. Well, users don't really want to hear that. I mean, the analog that I would sort of hear from people was, well, it's like you go buy a new car, and they say, well, it's kind of tuned, but if you really want it to run right, you got to take it home and do, fiddle with the carburetor or whatever, fuel injection. So, so that didn't settle real well with a lot of people, and so there is a user's expectation that it is better out of the box, and we could do that. So there's this long recognized need for validation. A couple of years ago, the folks at the Service Center produced a white paper on validation. It was sort of guidelines, and several groups, Justin being part of one, and I being part of one of them, actually did some validation work, some of it using FIA data, some of it not, in the other groups, according to this guideline. So we have sort of an approach now, but it's the opportunities now to get into some specifics. And like I said, this is a fairly new document, it's evolving, but that's what we're kind of basing this on. In that document, it talks about some characteristics of evaluation data. And says, well, continuous forest inventories, you're trying to calibrate a growth model, so you need multiple points in time, which you only get from CFI. Some states do their own, some don't. And then, of course, they mention us by name as being a good source of that. Then they talk about the data should have the same characteristics of the test scenarios. And so if you're dealing with a certain forest type, you ought to be able to find data that look like that forest type on those kinds of sites and do that. Well, we sample everywhere, all forest types, all ownerships. We probably have that pretty well covered as well. And then it quantifies the same attributes. Again, it's that same thing where we're representative. If we pretty much sample all but the rarest flavors of lodgepole pine forest, for example, that are out there. We've got some measurements on all ages, all site classes, all that sort of thing. And then the data should come from timescales comparable to simulation periods. Well, the eastern variants tend to run on a 5-year cycle as a default. The western variants tend to run a 10-year cycle as a default. Does that resemble anything we know from this morning? So the data collection and analysis are pretty in sync with the way that the simulators need to run. Now, you could do simple things, and I'll kind of skip through these since we crunched the time a little bit. But this is just a histogram of all of our plots and the values of Douglas fir stand density index. Okay, so we got some curve there. Well, if you're dealing with a stand that's way out, and you're trying to simulate something that's like an SDI of 650, well, you should know that you're dealing with excessively dense Douglas fir in terms of all the Douglas fir that's out there. So maybe you shouldn't expect it to behave like an average stand. So again, the users can put their simulations in context, and our data are fine enough to actually work out some fairly nuanced details. Like in terms of FIA forest types, we have a thing called Engelmann spruce, we have a thing called Engelmann spruce subalpine fir, and we have a thing called subalpine fir. And if you look at the characteristics of those across the whole population where we measure them, they're different enough to make differences in simulations. So if you're working with a stand or a group of stands that have spruce and fir in them, you probably want to know where they are in the mixture spectrum before you can really understand what they're supposed to behave like. This is another kind of interesting one because this is just a pattern that's cropped up in a lot of analyses was we done across the West in terms of forest growth is very sensitive to competition, shade tolerance, and things like that. And throughout many forest types in the West, you see this pattern where there tends to be a lot of acreage of a very pure type, a lot of acreage of types where that species of interest, and this could be ponderosa pine, aspen, whatever, is a very minor component of stands. And then a lot of acreage in between, almost like in thirds, of which just could be any 60-40, 80-20, whatever mix in between. Again, for the users, it's good to know where you are on that spectrum and make sure you're using data that come from that same range. So going back to the framework in the white paper, they talk about 3 approaches. verification, sensitivity analysis, and validation. And they kind of, if you're just going to catch it all in one word, people just say validation, but it really means a few different things. And so verification is the quick way to describe that is kind of a sniff test. You grow it, see if it looks like what it's supposed to, say, okay, yeah, that's kind of acceptable. Sensitivity analysis is kind of a different beastie because especially when you're talking about some of these complex submodels that have 8, 10 variables in them, how sensitive is it to a tweakage of one or more of those variables? That doesn't necessarily relate directly to our data, but I'll show you how it is somewhat related. And then the validation is the true kind of, getting in there and picking apart, the performance, more of a statistical analysis of the performance on the, of the models. So I'll just step through these real quick. And this goes back to an example used in several different talks. It applies in different ways. Also dates to before I came out here. I was working with longleaf pine on Department of Defense lands in the west and the east in North Carolina, and all the models we ever had, this is not FVS because they weren't using it back there then, they tend to be whole stand growth models, were way over projecting how much basal area of longleaf pine we get. Because this was like ball bearing sand, it was deep, didn't hold any water, and the guys that were working with us there, they were there for 20, 30 years, and they saw these things, and they weren't biometricians, but when they looked at the projection, they said, yeah, right, 180 square feet of basal area longleaf pine, I don't think so. Into the circular file it went. So I started on this quest, which eventually led to FIA data, of trying to disprove this idea that there was a range of stand density that just longleaf didn't go. It just didn't go there. And this sort of evolved in some of the density management work that I worked on once I came out to Utah working with Jim Long, and that we actually incorporated that into silvicultural tools like density management diagrams to say, hey, okay, here's a diagram that tells you about volume, growth, that sort of thing, but based on our data, there's a zone up there that you probably don't want to be planning on your stand moving up into that area. And so we actually started putting those limitations on the diagrams and describing that phenomenon. And so sure enough, getting back to FVS, the way it would tend to grow a stand would be to follow a self-thinning trajectory and then just keep on going forever and ever. If you grew it long enough, it would project something like that. And in reality, based on what the data say, we were expecting a stand dynamic, something like that. And so this is that initial verification step to say, well, if the model's doing, what you see in the upper right there in little red dots, right off the bat you're saying, well, we got problems because it shouldn't be going there. And of course, we look at certain things like that, and that phenomenon occurs in lots of other forest types. It's different in each forest type because of just the characteristic of the trees, how big they get, what the tolerance of them is, and things like that. But only with boatloads of data like we have in FIA program can we start to characterize these. Because you're looking at populations, you're not looking at the kind of local things. Now the sensitivity analysis, like I say, I'll just mention this briefly, but it essentially involves looking at a model, and this is part of one of the projects we did, looking at a large tree diameter growth model. This one has how many, 10, 12 or whatever parameters in it. And the sensitivity analysis really wants to analyze which of those are the most important. What's really most sensitivity. Your result is most sensitivity to height, to the height of the top, the 40 tallest trees or whatever. But in the sensitivity analysis process, you have to feed that process the range, some sort of distribution of the values that you expect. So you'd be kind of blind if you're going to go into your sensitivity analysis and you're doing longleaf pine, which gets to maybe 80, 90 feet in that area, and you're feeding it height values from 0 to 250. Well, that doesn't make any sense. We go back to the data and we say, okay, what is the range of that variable in the real world? Let's plug that into the sensitivity and only evaluate it within those range, because if you're outside that range, it's not very meaningful. So it helps to inform the analysis process. That's all I'll say on the sensitivity, but it does relate to the data. Validation is where the fun stuff is, right, Justin? And again, where you're doing more, you're comparing directly predictions to real stuff. And this is where we have the chance to kind of make the most hey, with comparing remeasurement data in FIA plots to what FVS is projecting. Sometimes you throw up your hands and say, well, it's not doing a very good job. Maybe further validation testing isn't really worth it. Let's just take the data that we have, because maybe it's better than what was done in the first place to fit the model. Let's just start from scratch and refit. And so we've done a little bit of exploring with that too, and it's pretty valuable for that. So so what we're shooting for here ultimately is an efficient validation approach or efficient validation process that takes what FIA can give and gives it to what FVS needs in a sort of programmatic way, and so that the both things kind of move along, coupled together, and we get it. So we have the framework. I say, how do we get there and where is there? Because we're really forming that right now. We have lots of data. We have the need. And the other thing is that a lot of this validation work to date, and not a lot of it's been done, it tends to be done by third parties. We don't have enough time to do it. They don't have enough time to do it. The users all want it, so who does it? And one thing I learned at listening to all the talks in Fort Collins a few weeks ago was that there was one guy who was he from Minnesota. He got up there, and he said, well, you know, y'all, I used FIA data for this project, and you know how easy that is to use. It's great. And I sat back there for a second, and I thought he was some kind of savant or something for, you know, getting into our data and having no problem. And then he talked a little further, and I realized it was really a sarcastic remark. So the truth is that the people who are out there who would really like to do the work, getting at the data is a big barrier to getting the work done. That's a lot, you know, that's a big part of what they do. So if we can facilitate that, all of a sudden, I think just having data there will really improve life for the users who want to just pull data off the shelf. Kind of like what Chuck was talking about. We want it sitting there, so if somebody wants to test it, they don't have to turn the crank and create it on their own. And whether we do that in-house or still farm it out, we don't know. So what we have in mind. So on the FIA, we got data, lots and lots of data. You know, we talked a little bit this morning about the cycles and all that. I won't go into that here. I talked a little bit more about in that Fort and Collins. And then we have this matching of the cycle length. But we're essentially to the point where we are truly data rich. The last few states are finally coming so that they're, you know, they've at least got one cycle under their belt and we're in remeasurement. Now the types of data are pretty broad. We're gonna crawl before we run, or crawl before we walk, then run. And so really right now we're talking the ones I have in blue, you know, condition plot, tree data, those basics. But FVS, like I said, does a lot of stuff. So ultimately down the road we want to bring in downwoody data. We want to bring in veg data as part of the contribution to the FVS program. So on the FVS side, we have these models, and there are lots of them. And so what we really need to do as a very first step, we've done this, like I said, very piecemeal so far, but we need to do it in a big way, is to crosswalk it. So here is an example in one of the models, one of the variants. You have this log of DDS, which is a growth variable, as a dependent variable, or the independent variable, and on all these dependent variables on the side here, how dense the plot is, you know, crown ratios, relative height of the tree, all that sort of thing, is we need to crosswalk that to what FIA has and answer the question first off the bat, can we address that particular equation, that particular problem? And we've talked about this. I think we're at the point where we can have them start doing the mining and produce what's essentially a catalog of models and variables. Then we go into our database and move over the ones we already have and then compute the ones that we don't have directly, table all that stuff, so you essentially have, like we're talking with the climate data, this big wad of FVS compatible data. The variables are defined the same, they're computed the same, and now you could just go into there and mine that if you want to enter validation. Then things like this, where you're doing all this direct testing, that's your main step. You don't have to worry about crunching all the data because it's already been documented, already been tabled, already sitting in a convenient place for you to use it. So that's where it takes us up to here in this proposed process. So we do the cataloging, we do the crosswalking step, we do this potential of mass validation, because we can, once we know how many there are, we can run it all through and do it more or less in bulk, where it's just getting nickel and dime to death right now. But there's more. If you really think about the way our data work, we have these 93,000 plots, or 30-some thousand with forest data on them. And we're going to have, we either have or will have these cycles measured over time, these remeasurement periods. Then we have, and I'm coding it by little, changes in color here, different disturbances, different treatments, all sorts of things we kind of know, notwithstanding some of the issues that, that Todd talked about with it being out of sync with the, with the measurement. We know something went on there. And so if you look at, this is the kind of data that we'll be generating over time. Now, if you take the same plots that we measured at time 0 and you project them over time, what essentially it gives us the opportunity to do is evaluate those plots projected at the end of each remeasurement cycle, and then go back, recalibrate from the beginning if we missed, and then run them again, and essentially run a continual validation process over time, so that FVS eventually becomes continually tweaked for longer and longer periods of time. It's not a one-time validation that you go out and you have a little project done and it's thrown in the box and you call it good. We're saying, okay, is it still working? 10 years later, is it still working? Is it still working? And refining the model that way. And so in terms of the process that we want here, we want to add a couple of more steps, is to kind of establish these, not really automated, but systematic validation cycles to coincide with FIA remeasurement cycles, so that at certain times in certain geographic areas, we take it all and say, okay, we're going to match what these stands that we measured 10 years ago, 20 years ago, whatever it is, and look at them, project them in FVS, and then look at them at certain benchmarks and judge their performance. So it's sort of a multi-dimensional, at least in time, sort of validation process, and not just a one step. So it becomes a continuous, you got basically a continuous validation coupled with the continuous forest inventory. I can't think of anything you'd have to complain about after that, because you either got the models fixed or they just aren't working right, if you don't have it done by then. So I think that's it for mine. Almost caught us back up. Any questions on it? Yes, okay. Yeah. Well, I think we could have all of the models documented in 1 to 2 years. And that's all variants, all submodels. Then Troy will probably have the 11 data published by then. So then I'll sit down with Troy and we'll do that next step, which will be to find, okay, what do we already have they're defined the same? DBH, duh, things like that. Then compute things like the log of DDS or whatever weirdo variable they have in there, because there's some gems in there. A lot of the old model fitting was all done during linear regression, so there's a lot of transform variables. So that's a lot of our homework, is just to take those, oh, here, we just need to transform this or square that or whatever we're going to do. Then we're set. Then I think there's going to be a feeding frenzy of validation. Justin's got it on his work plan because he comes here with that experience under his belt and an interest and desire and the expertise in FVS. Those guys are all on board totally from the top down, so they're going to help facilitate that as much as they can, mainly by being the folks who help document that. Yeah, and so 2, 3, 4 years, then we'd have then the process would be in place. Then the next step would be, okay, how do you do this in terms of that last kind of scary diagram with the flow of all those plots moving forward. But if you really think about it, we can, not only are you trying to validate, kind of tough to validate on one stand. And a lot of the simulations you do right now, you conjure up some various densities or various site qualities or something like that, and you run them through and see how they behave. We could take real data, define what we want. Okay, we want lodgepole pine, aspen mixes between 60-40 and 40-60 of composition on this range of site quality. How well do those guys do? Project them over time, because we could just pull them out of our database by our design, project them through time, and then match the projections to remeasurements of stands that look like that over time too. So that's a whole different dimension to validation, because you're doing it real stands and not just conjuring up these kind of ginning up examples and just for sensitivity sort of thing. So that, I think, has potential. And then I think the users, knowing the silviculture community how I do, they'll get much warmer fuzzies over that when you can show them that I took 50 stands, 40 of the stands sort of, you could start to, because they're going to go zooming all over the place, right? I mean, every stand is a little different. So you're going to say, okay, 80% of the time I'm hitting the basal area on this range of defined forest type within plus or minus 10 or 20 square feet or whatever it is. You can put that on there, whereas right now the simulation is more of a theoretical sort of approach. And I think that having that more empirical process will really go a long way towards building user confidence. I also work with a lot of the academic users of FVS, and last year after our steering team meeting, I sent out sort of an informal poll to see who's using it, why they are, why they aren't. About 20% of the universities, in terms of like silviculture professors, ecologists, are using it in teaching or their research. The ones who don't they'll say, well, yeah, it's nice to do a simulation, but it's not producing realistic projections for my part of the world or whatever. So they might use it just to teach examples, but not necessarily encourage its use for actual simulation. So there's a lot of that stuff going on, and so it's kind of convincing one mind at a time. Yeah, Mike asked if the eastern FIA regions are buying into this validation process. Some of the validation is going on in the east, and they are using FIA data. But again, it's the barriers there, because those poor suckers have to slog through the bare tables and work, because there's just nothing for them to pull off the shelf that's amenable to validation. So we're trying to make life easier for them, and get more people involved in it, and more people that get involved and do the validation, the more that probably will use it. But we got some pretty sharp folks in the east, some of whom have pretty direct connections to the FVS community for a long time, and they're doing that. Not so many people in FIA, because even National Forest Systems in the east don't use FVS all that much. They're still, the east and especially the southeast is still whole stand table projections and things like that. But this is a tremendous tool. Okay, with that, I'll turn it back over to Michael for the grand finale.
All right. Thank you. Now you've heard from us. We've given you a lot of talks all morning long and all afternoon. We've heard a little bit from you, hallway talk, and a couple of questions, but we would really like to get your feedback on our program. We're not going to spend the next hour sitting here trying to pull your teeth. You've seen John's email posted up there all day, jd.shaw@fs.fed.us. If you don't have that memorized by now, you still have a few minutes. It'll be up there. And we would like to hear back from you on not only on the information that was provided and your questions about that or your concerns, but also about this process. This is I think our third year now trying this web approach and in-person meeting, and so I'd like a little feedback on that as well. I'd like to thank the presenters. I thought you did an excellent job from my perspective today. You did a great job. I always enjoy even hearing my own staff talk about what's going on, because I don't always get the details day to day, and this is a fun part of the job, is the science and analysis that's going on. So thank you for that. Thank you all for participating, both online and those that came to the meeting. I appreciate it. Well, we've got some pubs here in the back. If you get on our website, FIA.fs.fed.us. You can click on our region and get into our library and description of job opportunities and activities that are going on. And if you see something you like or you don't like, please be sure to holler, because really what we do is a public service for science and managers, and we want to be able to provide you the right information. It's a huge investment. You saw the little charts at the beginning of the day, $70 million, and 14 million are coming to this region to collect data and provide information. So, we want it to be utmost useful to you. So, again, thanks for participating. Question about? They're going to be posted.
Probably take me a couple of days to get it on the web, but we'll at least post it on the extension, USU extension forestry website, but you'll probably get an email with it.
Yeah.
Could you encourage the people online to fill out those polls?
Right, yeah, good reminder to fill out the polls if you're online. We'd appreciate that. We've got some information from you online, and those of you here in the room, we routed around a little page you can stick your email, and that's how we'll make sure we keep in contact with you. Don't wait till next year's meeting. We like having the contact, and some of you are, pretty proficient at that, of knocking on our door or making the phone call. And as I mentioned to some of you yesterday, if you need help, we'll send a crew out to where you're at to visit and work with your staff to talk about any of these issues, to do trainings, whatever you need. So that's our job, and we like doing that. So again, thank you very much for participating. I appreciate your time today. I hope it was worthwhile, and fill out the polls, and we'll get this stuff posted for you soon. So that's all I got. Thanks. Have a good rest of your evening.
Anybody who's planning on being around